Okay, question 18. The curve y equal k minus 6x squared minus 8x plus k is to cut the x-axis at 2 points. If it cuts x-axis at 2 points, b squared minus 4ac must be how? More than 0. Excellent. Okay, everybody now knows this very well. So b squared minus 4ac must be bigger than 0. So your b is negative 8. My a is k minus 6. My c is just a constant k. So this is to be bigger than 0. Sherry, you alright? Why the question mark? Oh, okay. Nothing, yeah? So I expand. Okay. So I expand everything. I'm not going to show all the steps of expansion, yeah? I assume everybody know how to expand. I get this. Okay. Expand out properly. Oh, you know already. 64. Oh, okay. Sorry. Let me erase this. Okay, so I end up with this quadratic inequality once again. Okay, personally, I have a habit. I don't like the k square. I don't like the k square term or the x square term or the m square term. I don't like to have a negative coefficient. So I have a tendency to like to move everything to the other side so as to make the coefficient of k square positive. This is my habit. So I move everything to the right hand side like this. When do we need to use it? Okay, I answer Xingyi's question first. Yeah, you use discriminant whenever you are dealing with, number one, nature of roots. If the question says something like the quadratic equation, the quadratic function has 2 real roots or 1 real root or no real roots, then you always have to look at discriminant. Okay, that's the first case. Or when they say something like the graph is always positive or negative. And remember, we talked about it in class. When the graph is always positive or negative, that means the graph must be hanging up there or hanging down there. Means there's no real roots. You also use the discriminant to help you. The third case is when we talk about intersection of two graphs. When two graphs intersect 2 times, then the discriminant must be bigger than 0. If intersect 1 time, then equal to 0. If intersect no time, doesn't intersect at all, the discriminant is less than 0. So these are the 3 cases usually we use discriminant to help us solve problems. Okay? Okay, continue. You need practice to get the hang of it. So for now, we are still just started learning, so it will be a bit shaky. So here, why I use discriminant to help me is because the question say the curve cuts the x-axis at 2 points, which means it has 2 real roots. 2 real roots. And since 2 real roots, it tells me the discriminant must be bigger than 0. So I put in the b, the a, the c, and I let it be bigger than 0. Okay? So I move the negative 4k squared over, move the 24k over, move the 64 over, so that my k squared becomes positive coefficient. This is a habit of mine. Okay, let me just rewrite it so that the left hand side and the right hand side just swap position, just swap only. Edison, when you move if it's an addition and a subtraction, you do not change the alligator, that jaw sign. No, only change it, only flip it around when you do a division or multiplication of negative numbers. Okay, so do not flip the inequality sign. You are doing addition. Flip only if you are dividing or multiplying by a negative number. So in this case, when I bring the 4k square over, it becomes positive 4k square. I'm doing an addition. When I bring the 24k, I'm doing a subtraction. When I bring 64 over, I'm doing a minus 64. Hence, you see, it's all subtraction, addition. Hence, my inequality sign remains this way. No change. Okay, Edison? Okay, then from here to here, I also never change the sign. I just flip the, as in the left hand side becomes the right hand side and the right hand side becomes the left hand side so that it's clearer for me to see. So you see the alligator sign, the mouth is still facing the 0, just like before. No flipping, I did not change the inequality sign. Okay, and the next step would be to simplify this. I realize there's a common factor of 4, so I'm going to take it out. Okay, always simplify before you do any complicated solving. So I have 16 here. Okay, take out common factor 4. Okay, addition here. I want to get rid of the 4, so I bring the 4 over. It becomes a division. Edison, do I change the sign of the inequality? Okay, you see, I'm dividing by 4. If I divide by 4, is 4 positive or negative? So if I divide by positive number, the sign should not change. You only change the sign if you divide or multiply by negative number. Okay? So you see my alligator, the mouth is still facing the 0. Okay? Okay. So now my inequality is now simplified to this. So this is the inequality I'm trying to solve. K squared minus 6k minus 16. So this is the quadratic inequality that I'm solving. Okay? So what is the first, every time we want to solve a quadratic inequality, what do we do? I haven't talked to Nicole yet. Nicole, what's the first step I do? Is Nicole still here? Nicole? Okay, before I factorize, I will let it be 0 first, right? Okay, solve it like an equation. Then factorize like you say. This one will be minus 8 plus 2. Agree? So your two values are 8 or negative 2. So these are my two k values. What's the next step after that, Natasha? Oh, okay, I have found the factors. I found the k values where the equation is 0. What do I do now? Sketch the graph. Exactly. Sketch the graph. So I sketch by the side. Okay. This is going to be a smiling or frowning curve. Smiling because k square, positive k square. And the roots are minus 2 and 8. How come? Because of this step here. I found the factors already. So this is something like this. Okay. Go back to the inequality. What am I interested to find? The less than 0, the negative parts of the graph. So we're interested in here, the negative parts of the graph. Okay, negative parts, because it's less than 0. Jinglong, what's your answer now that we have identified the region I'm interested in? Is Jinglong here? Okay, never mind. Xingyi, yes. Xingyi, can help me? What's the region? What is the value of k I'm interested in? Since I identified the red portion already. K must be between -2 to 8, right? This is the portion I'm interested in. So K must be between -2 and 8. Do I put the equal sign? Sherry, why no equal sign? Yeah, because the question itself doesn't have equality. Okay, so usually we will stop here. This is my answer. But in this question, you have to be a bit careful. The question says, the question continues. Actually, the question gave me another information. It says this graph has a maximum point, which means only quadratic curve is always smiling or frowning. To have a maximum point, this quadratic curve must be frowning. Right? That will give me maximum point. And if it's frowning curve, we know that the coefficient of x squared must be less than 0. So let me write down, okay? Since the graph, original graph, has a maximum point, it must be frowning. Okay, we're talking about the original equation, not the subsequent one involving k. So it must be frowning. Since it's frowning, the coefficient of x squared, k minus 6, must be less than 0. It must be negative. Change what sign? See, change what sign? Which one? Yeah, I know what you're saying. Are you talking about this part? Are you talking about this part here? Between here and here? I did not change the sign. At first it was bigger than 0. This part you okay? Because cut x-axis 2 times. Then after that, yeah, still bigger than 0, still bigger than 0. Then I want to make k square positive coefficient, so I move everything to the right. So at no point did I flip the inequality. No, I did not. Y becomes smaller. Which one becomes smaller? Tell me which inequality here. Yeah, here got a lot of inequalities going on, so it's a bit confusing. It became less than 0 because I shift the minus 4k squared to the right hand side. Okay, see, yeah, we go through one step by one step. This part, you understand? Do you understand first step? Okay. Do you understand second step? Okay, you understand? Third step, this is just expansion. Okay, then do you understand how I got from this step to this step? How come it now go to the right hand side? Yeah, correct. So when in the process of moving, you see the inequality sign still stay like that. It did not flip. Oh, cause there's a black rectangle blocking. Wait, what black rectangle? Anybody got the black rectangle thingy? Like one thing? You also cannot see, Oh. Wait, let me see. Okay, wait. Huh, you mean all along you cannot see, Very funny. Now can see? Still cannot see? Okay, wait. Shall I start over again? Can I start? No need to start ah. Then what should I do? Tell me. Just scroll down. Okay, let me try. Is it like that? Okay. A bit more. Oh, sorry. Like this. Like that, can you see that? What's that black square? Okay, so I go on ah. Okay, so Xingyi, you understood how I got from first step to second, second to third. Okay, then from here to here, you know how I got it? Yeah, all I did is like, you know, left hand side, right as right hand side, right hand side, right as left hand side. Nothing else. And the inequality sign, the mouse still faces 0. Okay? Okay, then this step to this step, you know what I did? I just took out 4, common factor. Yes. It's because I brought the negative 4k square over, so it became less than 0. Because I want to make the k square positive coefficient. I actually did not flip anything at all. I didn't flip the inequality sign. Okay? Okay, then once I get the quadratic inequality, I let it be 0 as per normal. I factorize it. I solve for k. Then draw the graph. And it's a smiling curve because the inequality is this. Always go back to your inequality and check what is it you're solving for. Smiling curve, less than 0 is here. So the k I'm interested in is between -2 and 8. Okay, but the answer doesn't say -2 to 8. It says something else. This is because, okay, I've got to scroll up a little bit. This is because the question say the original equation has a maximum point. For the original equation to have a maximum point, the original equation must be a frowning graph. And since it's a frowning graph, its a must be less than 0, and the a is k minus 6, which means the k must be less than 6. Okay? So we had this, and now we have this extra condition. K must be less than 6. So the final answer is k must be between -2 to 6. Cannot be all the way to 8, because k must be less than 6. Is that right? Sherry, yes? Which part you don't know? Okay, which part cannot? Why less than 6? Okay, you see, you look at the original equation. Look at the original equation right here. Original equation is y equal k minus 6 x squared minus 8x plus k. Okay, look at this. Can you see my handwriting? Okay, so now this quadratic graph can be smiling, can be frowning, right? And it all depends on what? It all depends on the a. If a is bigger than 0, we have a smiling curve. If a is less than 0, we have a frowning curve. Okay? The question says this graph has a maximum point. Means it has to be a frowning curve. Only frowning curves have maximum point. Smiling curve will have minimum point. So that means I must look, the a must be less than 0 lor. So this one is out already. So what's a? A is k minus 6. So k minus 6 must be less than 0. And therefore k must be less than 6. Okay, see? Okay. So this question has an additional condition you must meet. Brian, are you alright? Okay, any other tutorial question cannot do? I know 18 is a tough one. 22B, 23? 22B. Okay, 22B. Okay, the rest of you who has tried the questions and you check the answer and you could get the answer, you can log off now. I will see you tomorrow at 1 p.m. Okay, I better write down here. See you tomorrow at 1 p.m. I'll tell you what we're going to do, okay? We will be doing a HBL worksheet. Okay, I will send out the worksheet tomorrow after you log in. I will go through a few of the questions. The rest you do yourself. Okay, for the Wednesday session is KIV. We check progress tomorrow. If everybody is fine, we may skip the Wednesday one. Oh, one more thing. So for now, go and complete the rest of tutorial 5. Because I think some of the questions we haven't done. We have not done the dolphin question, number 11. Number 12 we also haven't done. And number 24 we also haven't done, I think. Okay, question 12, 11, 12, and 24. Okay. See you tomorrow. So the rest, no, the HBL worksheet I'll give out only tomorrow after you log in. I'll go through a few questions. Then you all try yourself. And like just now, give you some time to do, then ask question. Then if nothing else, then you can go. Oh, you saw it? Got me? Oh, okay. Then maybe, okay. If it's already there on BB, can you all try it on your own if you have time after doing the tutorial? Yeah, try, and then tomorrow I'll go through whatever questions you can do. Okay? The likelihood is Wednesday we need not have the session because I think y'all are okay. Okay? Okay, so going back to 22B. Question 22B. Audrey, you here? Okay. So the question says that the line intersects the curve at 2 distinct points. What do you know about two graphs intersecting at 2 distinct points? Yes, you can leave, my dear. Unless you want to see 22B. Yes, Diana. Bye-bye. Okay, so what I'll do is after this, after I finish 22B, I will send you all the recording for just now before the break, and then after that, this session now. I'll send it to you. Yeah, you can still watch it, don't worry. Okay, bye. Audrey, go back to question 22B. Tell me what you know about two graphs intersecting at 2 distinct points. Oh, sub 1 into 2 is for this kind of question, 22B, where you have 2 graphs and you are interested to find out what happens when they intersect 1 time or 2 times or 0 times. Yes, 2 equations. Yes, it will still apply because after you sub, you end up with a quadratic equation. and the fact that they intersect twice means the discriminant of that resulting equation will be bigger than 0 or less than 0 or equal 0 depending on how many times they intersect. So you go through, okay, I'll go through this question, then you see whether you understand. This one is just like more steps. Yeah, slightly more steps. You have to combine the equations to become one more extra new equation. That's the difference. Okay, so equation 1, equation 2. So Audrey, what I know distinct root. So what do you know about the discriminant later? How will the discriminant be like? Bigger than 0, exactly. So first I need to substitute equation 1 into equation 2. I need to do like simultaneous equation solving. So sub 1 into 2. Okay? Okay, so let's look at equation 2. Equation 2 is y equal x squared plus 6x plus k. So I see a y here. I'm going to replace it by this. Xing Yi got a very interesting question. Usually questions coming from this topic when it involves quadratic equation will have got to do with b squared minus 4ac. I try then all become numbers. What do you mean by that? Don't have, not always have alphabet, but do you remember last time earlier when we first learned about discriminant? Like for example, if you look at let me see. Not always is numbers. You got to show me, maybe later. Can you attach a file and show me what you mean by that? Can you take a picture and then you send attachment here? I'll take a look at what you're talking about because I don't get what you're saying. Okay, I continue first for this. So my y in equation 2, I change it to k bracket x minus 1. Understand why? Then how am I supposed to understand you? Okay, I expand. Kx minus k equal x squared plus 6x plus k. Okay? Okay, never mind. I'll help you. You wait first. Then what do I do, Audrey? Yep, move all to one side. Move all to one side. Which side? Which one will you move? Move left to right or right to left? Move right to left. So I'm gonna move everything here, okay? Why? I want to keep the x squared as a positive coefficient. I don't want to disturb the x squared. So x squared plus 6x plus k minus kx plus k equal 0. Okay? Now I tidy up. So x squared remains as x squared. 6x minus kx, this is the like term. So I take out the x, I have 6 minus k. Plus k plus k plus 2k equals 0. Okay, now this is the resulting quadratic equation. This results from me combining equation 1 and equation 2. And you realize this is quadratic once again. They say the two graphs are supposed to intersect at two distinct points. So based on this, I know that the discriminant, b squared minus 4ac, must be bigger than 0. Correct? Because this quadratic equation came from combining these equation 1 and 2. So the discriminant must be bigger than 0, since they intersect twice. Audrey, get me the B, the A, the C. The B, the A, the C comes from here. Don't look anywhere else. This is the combined one. The B. Nice. 6 minus k. The A is 1. And the C is 2k. Excellent. So this is to be equals bigger than 0. What do I do next? Expand. Nice. 36 minus 12k plus k squared minus 8k is bigger than 0. What do I do next? Tidy up. Nice. K squared remains. Minus 12k minus 8k is minus 20k plus 36 remains bigger 0. Okay. So look at this. This is a quadratic inequality once again. Quadratic on the left, inequality here. So to solve it, we'll do the usual. Step 1, step 2, step 3. Okay? Okay, tell me what are the steps. Step 1. Wait, I answer someone first. Yeah, let it be 0, exactly. Let the quadratic equation be 0 because I want to find the roots, right? Okay, factorize. K minus... What are the factors? 36. Did I copy anything wrong? What are the roots of 36? 12 and 3, 9 and 4, 18 and 2. Oh, thank you. Thank you so much. Okay, so I got the two roots. K is 18, K is 2. Next, what do I do? Nice, draw graph. So let's draw a graph. The graph is here. Smiling or frowning? Always check the inequality you are looking for. Yep, smiling. Okay, check the inequality you're solving for. The K is 2 and 18. These are the roots. Smiling curve. Go back to the inequality. I'm interested in bigger than 0. So we're interested in bigger than 0. Positive ends. The positive sides of the graph. So by looking at this answer, can tell me what are the K ranges? What is K? K must be K is bigger than 18. That's the right side. Left side. Less than 2. Very nice. Okay, now for this answer you need to break it out into 2 parts because you see my 2 sides are broken up. There's something in between them that is breaking them up. So my answer also is broken up like that. Other times when we're taking the in between part, the entire range is continuous. So you must know how to write the inequality in different forms. Okay? So this is the answer. K is less than 2 or K is bigger than 18? Yes, Edison. What do you mean by check back to the inequality? When drawing the curve, when you're drawing the curve, you want to know whether it's a smiling or frowning, right? How you know whether it's a smiling and frowning is to go back to the inequality that you're solving. In this case, I was solving this inequality. So this inequality, then you look at the left-hand side. The k square is a positive coefficient. Like after you get the values of k already, as in which step? Are you talking about this step or are you talking about this step? The bottom one. That means you're talking about... Oh, you don't know how to get here, huh? Okay. to get this, you must look at your graph. You understand why I chose this patch and not the middle patch? You know why I chose the red part here and not the middle part? Yeah, because I want positive, bigger than 0. And how you know is you look at the inequality you're looking for. You see bigger than 0. So I choose here and I choose here. Now if I continue drawing this graph, it will just keep going on and on. Just keep going on. So for all the k values that is to the left of 2, the graph will always be positive. So k must be less than 2. For all the k values that are to the right of 18, the graph will forever be positive, extend upwards. So k must be bigger than 18. The in between, I don't want, because that will give me negative output. So I don't want anything between 2 and 18, but I want anything that is less than 2, anything that is bigger than 18 for the k. Does that make sense? Okay, maybe I do. Okay, let's try this. I'm going to give you a few graphs. I'm going to sketch the area I'm interested in. You tell me how to write it into, let's say this is k. Tell me how to write the range for this part. One more. Let's say this is p. Tell me how you write the range for this part. Okay, first one. How you write? How would you express the part I want for the k values? Very good. Between k is between 1 and 4. How about the other one? Very good. P is less than -2 because I want all the p to the left of -2, and p is bigger than 5 because I want all the p's that are to the right of 5. Exactly. Okay, very good. Any more? Okay, I see you tomorrow, okay? 1 p.m. Bye. Jit, you okay? Yes, oh yes, Xingyi. How? You gotta send me to tell me what you mean. Bye. Bye, Audrey. Bye-bye. See, I'm still here. ALYSHA, you okay? Yeah, understanding what you want to ask is very important. ALYSHA, you alright? You understand? See, it's confusing because we're combining last week's concepts of discriminant with this week's concept of quadratic inequality.
No, it's like cause like they are like quite similar, so sometimes I cannot I can't differentiate the question types, then I cannot do.
Give
Yeah.
me an example of a question you cannot do. Like for example, what kind of question will confuse you?
Like I read like example they ask set values of x. And then this one is question 16 from the tutorial. Then like if they ask
I
the
get it.
solutions of the equation, yeah, I very confused.
Okay. Xingyi, question 16 is a very straightforward quadratic inequality. That means no need to use okay. Now I understand what you mean by no need to use discriminant. This question, they just want you to solve this quadratic inequality.
Only discriminant, right?
Nothing to do with discriminant. This one is purely okay. When to know, you must need the discriminant concept. When they talk about nature of roots, when they talk
positive,
about
negative.
so the graph position up there,
And
down
two,
there, always positive or
intersection.
negative, and then intersection of two graphs. Those you need discriminant. In the question 16, it's just pure quadratic inequality solving.
Yeah.
That one you just solve from the step of, you know, the what we learned today. That step onwards 就可以了。
I will practice more.
Yeah, you go and try the HBL worksheet also.
Okay.
ALYSHA typing very long. I think she got long story to tell me. Okay, for question 23, right after subbing in integration, I got this. How to combine? Okay, let me see. Question 23, you solve 5x squared minus 3kx squared equal minus kx. Oh, okay. I'll show you here, just that step, and then you try the rest yourself. 23 is like that. So you sub y equal to 5x squared into y equals to 3kx squared plus k minus 5x minus 2. Okay, so sub inside. You're right, sub this inside here. So you have 5x squared. At the same time, I bring all the terms over. Okay, I skip one step, I bring everything over. Okay, up to here? Okay, I know, these two are not quite the same. So never mind, take out x squared like common factor. You leave behind 5 minus 3k. Then the x term remains untouched. Remain like that. And the constant term also remains. So what's the k? What's the a? This is the a. So a is 5 minus 3k. What's the b, ALYSHA? Okay, so b, remember there's a negative sign outside, so minus k minus 5 like that. And c is 2. Okay, the rest you can do, I think. Lies entirely below. So b squared minus 4ac is? One last question, b squared minus 4ac is? Yep, no real roots. Okay, you try, and then tomorrow when we meet, if you still have questions, then we answer together, okay? Bye-bye. You're welcome. Carissa, ALYSHA, Xinyi. Xinyi is still here?